This is the largest collection of Hubble images ever released to the public simultaneously, and we are proud to share them with you today. Astronomers think that the first galaxies formed out of clumps of gas in the early universe. These protogalactic clumps then went on to coalesce and to merge together to form bigger and bigger galaxies as time goes on and as their gravity attracts each other. So what exactly happens when two big galaxies collide? Well, that is precisely what Hubble is showing us in these new images, where it has captured some of these merger events in the act. These cosmic collisions, beautifully portrayed in the new Hubble images, are not as swift and ferocious as we might think. They are not like collisions between everyday objects. They are slow, stately affairs that may take hundreds of millions of years to complete. In this series of images, snapshots of different pairs of interacting galaxies are seen, representing the different stages in this process. A gradual waltz of stars and gas choreographed by gravity. Despite taking hundreds of millions of years to eventually merge, the two galaxies of a pair actually approach each other at very high velocities, up to 1,000,000 kilometers per hour or so. Also, because the distances between individual stars are so large, it is actually very rare for two stars to hit each other. The hundreds of millions of stars in each of the galaxies all move individually, following the pull of gravity from all the other stars and the dark matter in the galaxies. These interwoven tidal forces can produce the most intricate and varied effects as the two galaxies pass each other and eventually merge. The new collection of Hubble images illustrates how galaxy collisions produce a remarkable variety of intricate and delicately interwoven galactic shapes. Typically, the first signs of an interaction appear during the first encounter of the galaxies. The tug of gravity teases out stars and gas from the passing galaxies, often building bridges between them. During subsequent encounters, long streamers of gas and dust, known as tidal tails, stretch out and sweep back to wrap around the cores. These long, often spectacular tidal tails are the clearest signature of an interaction and can persist long after the main action is over. As the galaxy cores finally approach each other, their gas and dust clouds are buffeted and accelerated dramatically by the push and pull of matter from various directions. These forces can result in shockwaves rippling through the interstellar clouds. Gas and dust are siphoned into the active central regions, fueling bursts of star formation that appear as characteristic blue knots of young stars. As the clouds of dust build, they are heated so that they radiate strongly, becoming some of the brightest infrared objects in the sky. Some of the galaxies show striking, highly distorted features. Dust lanes crossing between galaxies and long filaments of stars and gas extending far beyond the central regions. We see beautifully interwoven galaxies twisted by these gargantuan encounters. Triggered by colossal and violent interaction between the galaxies, stars form from large clouds of gas in dramatic and brilliant bursts of stellar fireworks, creating new blue star clusters. Here is an image of NGC 6670, a pair of overlapping galaxies seen edge-on that kind of resemble a leaping dolphin. Scientists believe that it has already experienced at least one close encounter and that it is now in an early stage of a second. The next image shows an astonishing pair of galaxies, composed of two spiral galaxies of similar mass and size, NGC 5257 and NGC 5258. The galaxies are clearly interacting with each other, creating a bridge of dim stars connecting the two galaxies, almost like two dancers holding hands while performing a pirouette. Both galaxies harbor supermassive black holes in their centers and are actively forming new stars in their disks. This galaxy pair, dubbed IC 694 and 3690, is thought to have already experienced one close pass some 700 million years ago. As a result of this interaction, the system underwent a fierce burst of star formation. In the last 15 years or so, no less than 6 supernovae have gone off in the outer reaches of the galaxy, making the system a notable supernova factory. The image of this beautiful interacting pair shows long tails sweeping out from the center of the galaxies. These are tidal tails of stars and gas that have been pulled from the distorted disks of the merging galaxies. So we can see that while each of these images represents the demise of two beautiful galaxies, the distorted destruction they experience also results in a flood of newborn stars and some incredibly striking galactic landscapes. If you would like to see all of the 59 new Hubble images, please visit our website at spacetelescope.org. This is Dr. J, signing off for the Hubblecast. Once again, nature surprised us beyond our wildest imagination.
For astronomers, Omega Centauri has been an outcast amongst globular clusters for a long time. A new result obtained by the NASA ESA Hubble Space Telescope and the Gemini Observatory provides a surprising explanation for Omega Centauri's peculiarities.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liske.
Welcome to the Hubblecast. Today's cosmic guest star is a very special object. Omega Centauri has long been known to be the largest and brightest globular cluster visible in the night sky. Now, a globular cluster is a nearly spherical group of tens to hundreds of thousands of old stars, tightly bound together by gravity and found in the outskirts of many galaxies, including our own Milky Way. Beautiful but enigmatic, Omega Centauri has always been a bit of a puzzle to astronomers.
Omega Centauri lies in the constellation of Centaurus and is visible from Earth with the naked eye. It's one of the favourite celestial objects for Southern Hemisphere stargazers, appearing almost as large as the full moon when seen from a dark site. Exactly what type of object Omega Centauri is has long been a contentious topic. It was first listed in Ptolemy's catalogue as a single star nearly 2,000 years ago. In 1677, Edmund Halley reported it as a nebula. In the 1830s, the English astronomer John Herschel was the first to recognise it as a globular cluster, a classification that it has kept ever since.
Omega Centauri has several characteristics that separate it from other globular clusters. Compared to a run-of-the-mill globular, Omega Centauri has a highly flattened shape, it rotates faster, and it includes several generations of stars, which is an unusual feature for globulars, which normally contain only a single generation of old stars. Moreover, Omega Centauri is almost 10 times more massive than other globular clusters, almost as massive as a small galaxy. Now, new images obtained with the Advanced Camera for Surveys on board the NASA ESA Hubble Space Telescope and data obtained with the GMOS spectrograph at the Gemini Observatory show that Omega Centauri appears to be harboring an elusive intermediate mass black hole at its center.
The black hole was discovered after astronomers measured the motions and brightnesses of stars at the center of Omega Centauri.